So today we'll be continuing with data reduction method. So we have already seen some correlation-based methods and such methods for data reduction, and we also saw feature extraction using principal component analysis. Right, these are the methods we have come across. So today we'll finish with the data reduction methods before moving on to the actual machine learning algorithms. Okay, so first of all, what do you mean by attribute subset selection? Okay, so we know that we have many attributes. We collect as many attributes as possible, and we try to find the ones which are most relevant to our problem. Those are the ones which we use for model building. Okay, and so many attributes may be the attributes which we select. Many of them may be irrelevant to the mining task, or they might be redundant. So we talked about redundancy earlier, and some might not be relevant. So one method is for the domain expert. He or she can actually pick the useful attributes, but this is difficult and time consuming. Okay, especially when the domain, we do not know the behavior of the data in the particular domain. Sometimes we are able to identify what are the possible attributes when the domain is known to us. Say for example, we are going to find out about student performance in college. Since the domain is familiar to us, we might be able to identify what are the attributes which we need, but the expert can do it. But in certain other domains we might not be. Say for example, in medical domains, it's only the doctor who will be able to. Doctor is the expert there, so you need some human intervention, which is actually difficult and time consuming. So we use other methods. So in attribute subset selection, it reduces the data set by removing irrelevant or redundant attribute dimensions. So find the minimum set of attributes, which is the resulting probability distribution of data classes is as close as possible to the original dimension. So basically, we start with the data which we have collected, data in terms of the number of attributes. And we want to have the minimum set of attributes. We want to reduce it to the minimum number of attributes possible. At the same time, the probability distribution of data, that is the behavior of data, has to be the same, or the information which is retained has to be the same, but at the same time keeping the number of the attributes to a minimum. So one of the methods is for to go for an exhaustive search policy. That is, if you have n number of attributes in the beginning, you go for all the possible 2 raised to n subsets and find out which one is the optimal one using some method. But that is prohibitively expensive, and that is why we go for heuristic based methods. Which heuristics? One of the heuristic based methods is greedy method. Means you find the first attribute which is relevant and keep adding on attributes. That is a greedy method, right? So that is the method generally followed. So, first of all, what you do in order to greedily is they identify the best attribute using a greedy method is you use some metric to identify attributes or rank the attributes based on which one is the best. Okay, so the best attributes are determined using some test of statistical significance, which assume that the attributes are independent of one another. Okay, information gain is a measure which is used for ranking attributes. This is one. Information gain can be used in when you are going for model building. This is one thing which you can use for ranking the attributes, and then you can actually keep adding. Okay, this is one measure. We'll talk about information gain in detail when we are talking about decision trees for classification. But right now, just understand that information gain is a measure which can be used for ranking attributes. So once the rank is decided, then you can actually go for stepwise forward selection or backward elimination or a combination of both. Okay, so the procedure start with an empty. In case of stepwise forward selection, the procedure starts with an empty set of attributes, and the best of original attributes is determined. So we said we also already have a ranking of attributes added to the reduced set, and at each subsequent iteration, the best of the remaining original attributes are kept added. And this is continued until you reach the required number of attributes or until a threshold value for, say, information gain is actually reached. Okay. Stepwise backward elimination is a reverse of forward selection. So procedure starts with full set of attributes and then you remove the worst set of attributes at each step. Again, the final stopping condition is for you to um, reach a threshold. Okay. Another method is combination of forward selection, backward elimination. So stepwise forward selection, backward elimination, a combination of these. That is, each step, the best attribute is selected and the worst attribute is removed, and so on. Okay, decision tree induction we'll talk about when we come to classification, where it can be used for attribute selection. Okay. Okay, so this is one method of data reduction. Another method is parametric data reduction. Parametric data reduction means generally we have a large volume of data which might be represented using a set of parameters. Say, for example, in the case of linear regression means you have a data set. Say, for example, say you're plotting a data like this. Say you have lots of data. Okay, we have some data like this. Say a representation of age of people in your class or any in the college or something like that. Okay. And say we have a data like this. And in the case of linear regression, what we try to do is we try to estimate or try to find a line, estimate a line which passes through all the data, such that you have maybe this is one a line which can pass, or maybe we can have another line, uh, something like this. Okay, basically you can draw any number of lines like this, and we want to find the line. Sorry, we are estimating lines, not curves. Okay, so you can have any number of lines which pass through the middle of the data, and what we want is the best line which can model this behavior of data. Okay, so what we do is, so line is actually represented by a line equation y is equal to mx plus c. So the idea of parametric data reduction is you try to estimate parameters m and c, the slope and the y-intercept. So which means if you have a million data points, so those million data points can actually you represented using two simple numbers m and c. So it is represented using a set of parameters. So data reduction, so which means that your modeling application does not have to actually handle all the millions of data points. It just have to it just has to handle these data items. That is the idea. And in the case of linear regression, okay, so the data is represented using simple parameters MNC, and how do you find those parameters from the data? So that is solved in the case of linear regression, use method of least squares. So basically what you do is, if you have a line like this, you find the distance of each point to the line. Okay. And you from both directions you can have, say if this is a line, you can have points like distance can be represented using these lines. Okay. So you find the difference of each of these points, or the distance of each of these points from the line, and you try to find the line which minimizes. That is called the error loss function or the error. So you try to minimize that error. Okay, error means distance of each of these points from the estimated line. Okay, that is being minimized. So ആ minimum ആയിട്ടുള്ള ഏത് line ആണോ, that is what we choose as our representative line for the data, and you can actually use the MNC values for that line to represent the data. So that is what parametric data reduction is. And finally, this is the last method of data reduction which we are going to talk about. So we have got what is known as histograms. So I think we are all familiar with what histograms are, right? Histograms are actually use binning. That is, you group data into bins. to approximate data distributions and are a form of data reduction. And histogram for an attribute, say A, actually partitions the data distribution of A into disjoint subsets referred to as a buckets or bins. The data is actually grouped into buckets or bins. And these buckets either can have a single value or can have a range of values. Say for example, so these are histograms. So you've got a data set given in a text, and based on this, these are the bins. So if you have only single attribute corresponding to it, say for example, you have got one. One is actually has there are two occurrences of one, so that is why we have a bin like this or a histogram plot like this. Similarly, the next data item is 5. There are 5 numbers of it, so you've got 5 corresponding to 5. You've got a bar like this. Okay. Similarly, for each of these, a bar is drawn. So this is a histogram where every bin has only a single value. The same data can actually be represented using this distribution also. So here in 1 to 10 range, you've got maybe 12 values, and 11 to 20, you've got 25 values, and so on. Okay, so this is a method for estimating the data in each of these ranges. Say for example, you want to estimate, say we have got COVID vaccination, right? So there are different maybe the people who are doing the vaccination, the government or the health department, it wants to estimate the number of people in each of the range of values. Okay, to estimate what proportion of the vaccines have to be kept for each of the age ranges, say 18 to 45, 45 to 60, and 60 about. Those are the ranges. So similarly, they can actually come up with an estimate like this or a histogram plot like this in order to um, okay. So with that, we come to the end of data reduction method. So till now we have been looking at different we've looked at data, the different types of data items which we might come across. And then we said in order to do model building, basically what we want is to develop machine learning algorithms for specific applications. And before going for model building for machine learning applications, we have to actually process the data first. And we said there are many data pre-processing steps that we have to do. Data cleaning has to be done, missing data has to be eliminated, the range of values. Okay, data normalization has to be done. That is, all data items has to be brought to the same range. Otherwise, some of them might get more weightage in the model building process. So data normalization is something that has to be done. So after data pre-processing and data normalization, then we can go for data reduction techniques. So we talked about feature selection as well as feature extraction methods. Okay, so once we have gone through all these data processing techniques, then we can actually move on to the actual model building process. And in our syllabus, we'll be covering broadly. So when we discussed machine learning techniques in the beginning as an introductory class, then what we talked about is there are broad categories like supervised learning, unsupervised learning, say reinforcement learning, semi-supervised learning, and so on. Okay, so mainly supervised learning means generally we talk about classification methods. So classification, and then unsupervised we talk about clustering. Okay, and in our syllabus we'll be mostly covering different algorithms for classification, clustering, and association rule mining. Those are the techniques we'll be looking at next. So in next class onwards, we'll look at different classification methods for machine learning. Okay.